Hello friends, today we will study a first lecture of Laplace transformation. In this lecture, we will study about the definition and the derivation of some important formulas. And if time permit, then we will also discuss some example of it. What is Laplace transformation? If small ft be a real valued function defined over the interval minus infinite to infinite such that ft equals to 0 for t is less than 0, then Laplace transformation of this ft is defined and denoted as LFT is equals to Fs, which is equals to integral 0 to infinite e raised to power minus st ft dt. This small s is a Laplace variable. In some book, this s is replaced by small p. So either small s or small p is written in the books. So there is no problem whether there is small s or small p. And this is the standard formula of this Laplace transformation. We can say it is a first principle of Laplace transformation. So we are taking first formula, Laplace of 1 is equals to 1 upon s. How can we find this particular phenomenon? So from let it is equals to 1. So from equation 1, putting ft equals to 1, what do we get? Laplace of 1 is equals to integral 0 to infinite e raised to power minus st into 1 into dt. And the integral of e raised to power minus st is e raised to power minus st upon minus s under the limit 0 to infinite. On putting limits, that is minus 1 upon s e raised to power minus infinite minus e raised to power 0. So the value of e raised to power minus infinite is always 0. E raised to power minus infinite is equals to 0. So Laplace of 1 is equals to minus 1 upon s, 0 minus 1, that is 1 upon s. Now this is the second formula, Laplace of t is equals to 1 upon h square. Again, from equation 1, putting ft equals to small t. So Laplace of t is equals to integral 0 to infinite e raised to power minus st into t dt. Now apply ilet by ilet, it is equals to 1 upon h square. Similarly, we can find the Laplace transformation of t raised to power n, which is equals to n factorial upon s raised to power n plus 1. Fourth formula is Laplace transformation of e raised to power at. How to find? Again the same condition apply. Put e raised to power at in place of ft, then integrate the function and we get the value 1 upon s minus a. Similarly, if there are e raised to power minus at, then the formula will convert into 1 upon s plus a. Next formula, Laplace transformation of sin at, which is equals to a upon s square plus a square. Laplace transformation of cos at, s upon s square plus a square. Now this is the first question based on this Laplace transformation. Find Laplace transformation of ft equals to 1 when t lie between 0 to 1, t when t lie between 1 to 2, and t square when t lie between 2 to infinite. So we are taking a first principle of Laplace transformation. From Laplace of ft is equals to integral 0 to infinite e raised to power minus st ft dt. or we can write it as integral 0 to 1 ft e raised to power minus st dt plus integral 1 to 2 ft e raised to power minus st dt and plus integral 2 to infinite ft e raised to power minus st dt. So on replacing the value of ft for each case, we get integral 0 to 1 into e raised to power minus st dt plus integral 1 to 2 t e raised to power minus st dt plus integral 2 to infinite t square e raised to power minus st dt. In this second and third case, we have to apply the eyelet, and after applying eyelet, on solving these integrations, we get 1 upon s plus 1 upon s square e raised to power minus s plus 2 upon s plus 3 upon s square plus 2 upon s cube into e raised to power minus 2s. This is the answer of this problem. Now this is the second question. Find Laplace transformation of 2 sin 4t cos 2t. So from this is ft is equals to 2 sin 4t cos 2t, and we have to find the Laplace transformation of it, and we know we have the formulas for the single functions, but there are two functions in product. So first we have to segregate these two functions into two different terms. That is, we can apply a formula 2 sin a cos b, which is equals to sin a plus b plus sin a minus b. So ft is equals to sin 4t plus 2t plus sin 4t minus 2t. So ft is equals to sin 6t plus sin 2t. Now taking Laplace transformation on both sides. So Laplace of ft is equals to Laplace of sin 6t plus Laplace of sin 2t, and we know the value of Laplace of sin at is equals to a upon s square plus a square. So in this case a is 6 and in this case a is 2. So Laplace of sin 6t is 6 upon s square plus s square, and for the Laplace of sin 2t is 2 upon s square plus 2 square, or 6 upon s square plus 36 plus 2 upon s square plus 4. So this is the complete solution for this kind of problem. Now this is next question. Find the Laplace transformation of t raised to power minus 1 by 2. So we have Laplace of t raised to power n, which is equals to n factorial upon s raised to power n minus 1. So Laplace of t raised to power minus 1 by 2 is equals to minus 1 by 2 factorial upon s raised to power minus 1 by 2 plus 1. But we cannot find the value of minus 1 by 2 in factorial. So we have a relation n factorial equals to gamma n plus 1. So we can convert it into gamma 1 by 2 plus 1 upon s raised to power half. This will convert into gamma half, and the value of gamma half is square root of pi. So Laplace of t raised to power minus 1 by 2 is equals to square root of pi upon square root of s. Now change of scale property. If Laplace of ft equals to fs, then Laplace of fat is equals to 1 upon a fs upon a. For this we are taking one example. If Laplace of sin t is equals to 1 upon s square plus 1, then find Laplace transformation of sin 7t. So here a is equals to 7. From change of scale property, this particular. So Laplace of sin 7t is equals to 1 upon 7 f s by 7, since this is fs. So putting the value 1 upon 7, 1 upon s by 7 whole square plus 1, and on solving we get 7 upon s square plus 49. So we can solve problem by scale property also. So there are multiple methods to solve a problem. Hope you understand the content of this particular lecture. If you like this lecture, then like and subscribe my channel. Thank you.